Hello and welcome to our last lesson of our first triangles unit. We're going to have another triangles unit on right triangles specifically, but this triangles unit is wrapping up with isosceles and equilateral triangles. Go ahead and grab this, pause the video as needed. Get this title down as well on our actual page. This is my page 31. And let's get into it. And as we know, we've already defined an isosceles triangle is a triangle where two sides are congruent and its base angles are congruent. And we've already talked about this, and just in case you don't remember, when we're talking about an isosceles triangle, let's call this, for instance, let's draw one really quick. Let's call this TRI. And if we have two sides that are congruent, then the base angles are congruent. So that would mean angle R and angle I are congruent because they are always opposite the sides. So these are your base angles. Which are angle R and angle I. We also have, we would call this the base. RI would be the base. So that's the actual side or the segment. And then we call this, once again, we call this the vertex. And then the two sides that are congruent, we call these the legs. So the legs are TR and a TI. So there's your isosceles triangle. And we use this actually in proof writing and proofs because if it's often stated if sides and angles. That is I personally would not say that because what they're saying is if sides are congruent in a triangle, then base angles are congruent or are congruent in a triangle. But some people shorthand it and say if sides then angles. That is not correct because it is not specific enough. So what some people do is they'll do this in their diagram or in their reasons. They'll do they'll show sides and then an arrow and then show angles. And notice that's where this comes from. If sides are congruent, then base angles are congruent. But they shorthanded to if sides then angles. That is not correct. This is what it should say. If two sides of a triangle are congruent, then the angles opposite to the sides are congruent. And these are the base angles. I'm just putting this in parentheses just as a reference for us. This is not necessarily in the proof. The base angles. Oops. Let's fix that really quick. Then the base angles are congruent. Okay. So the converse to this is also true. If you have base angles that are congruent, or if you have two angles in any triangle that are congruent, then the opposite sides, by definition, will also be congruent. Okay, and this is one would some people shorthand this is if angles then sides. That is not a good enough explanation. A picture is a good explanation as a reason, or if you write this out, if two angles of a triangle are congruent, then the sides opposite to the angles are congruent. Okay? Now, that pretty much wraps it up for isosceles triangles. We also need to talk about equilateral. Equilateral has its own kind of if-then. So here if we have an equilateral triangle, is a triangle with where all sides are congruent. Let's say where all sides are congruent. And this is where we talked about it. If it is equilateral, then it is equiangular. So I'm going to actually put at the tail end of this where all sides are congruent, and then in parentheses and, actually not in parentheses, and all angles are congruent. In parentheses, I'm going to, as we know, they should all be 60 degrees. All angles should be 60 degrees. So if it's equilateral, then it's equiangular. And if it's equiangular, then it is equilateral. And that is your if then. So this goes both ways. It is biconditional. The converse is also true. And let's do that. I don't know why I did all of this in red. Let's just change that for my sake. Okay, so let's draw a picture first, actually. That'd be probably more helpful. If we have all the sides congruent, then all the angles will also be congruent, where all of them are equal to 60 degrees. Okay, now, here's your if then. If a triangle is equilateral, then, or better yet, if all the sides in a triangle are congruent, then all the angles are congruent. Let's go there. If a triangle, let's start this over. If all three sides of a triangle are congruent, then all three angles of the triangle are congruent. And the converse is also true. If all three angles of a triangle are congruent, then all three sides of the triangle are congruent. Okay? All right. Now we have one more small piece to add to this, and this has to do with perpendicular bisectors. Now we know what perpendicular means. It's two segments, lines, or rays that form a 90-degree angle. Perpendicular bisector. And we know what a bisector is. A bisector is something that divides a segment and angle into two equal parts. So what's happening here is if we have a perpendicular bisector in an isosceles or equilateral, in isosceles or equilateral triangles, so this is a little subcategory, then a couple things happen. First thing is it forms a 90-degree angle at its base. 2, it bisects the angle, always. These are always statements. It bisects the angle. And then 3, it bisects the base. So a lot of things are actually going on here. So for the sake of it, let's draw a isosceles triangle. Make it equilateral. If it's equilateral or isosceles, remember it qualifies because technically an equilateral triangle is by definition isosceles because at least two sides are congruent. If we say that this is a perpendicular bisector, perpendicular bisector. Okay. Then let's call this COAT. OT is a perpendicular bisector. That means, one, it's creating 90-degree angles at its base. It is bisecting the angle it's passing through, so it is actually passing through this angle, COA, so that it's creating two congruent angles. Call this 1 and 2. So we could say, for instance, here, let's do this right here. We could say in blue, we could say angle CTO and angle ATO are right, are 90 degrees. It bisects the angle it is passing through. That means angle 1 is going to be congruent to angle 2. And then last but not least, it's bisecting the base. So that means we have two congruent segments here. I'm putting two ticks because these already have one tick and one tick. So we could say CT is going to be congruent to AT. Okay? And now we have what perpendicular bisectors do to isosceles and equilateral triangles. Remember, it is both of these things. If it's equilateral, it will work as well. I made it equilateral. If it's isosceles, this will work as well. So, a lot of new information, but none of it, these first two we kind of already knew, except now we have if-thens for them so we can use them in proof writing. This is the new concept, so make sure we get those down. Ask your questions if you have them in class, and I will see you in the next one. Bye.